Hello and welcome to the next part of this video series on making the ATTiny a slave device on the I2C bus. So in my last video we managed to get the board up and running, or the prototype board up and running with the ATTiny85 as the slave. We'd also managed to put in a command structure which allows us to remotely program the I2C address for the ATTiny and to store that in EEPROM. Now, in this video, what I wanted to do is add the ability to add some more functionality to the command interface. In particular, I wanted to be able to add the flashing function. I'm sure if you've used a 7-segment display clock before, when you go to change the date or the time, generally the segment that you want to edit starts flashing. Now we could keep this where the master on the I2C bus keeps sending down the commands to turn the LEDs on or off, but I thought since we've got this command interface, we've already got a microcontroller managing the board, why not offload some of that functionality onto the ATTiny? So that's what I've now done. So if we now take a quick look at the sketch that I've created, let me just bring up the right sketch. So this is the sketch for the ATTiny. Now all of these files I will be uploading onto my website, and the link for that you'll be able to find in the comment section below this video. So please feel free to go take a look at the code I'll be putting up there, and then you can see exactly what I am changing, but I will be going through it here. So fundamentally what I've now added is some variables to hold a flash pattern, which is a bit sequence 0 through 8, although we've only got 6 digits to flash. But basically bit 1 is the far right, is this one, 2, 3, 4, 5, 6, 7. So if I was to write 1 into the flash pattern, then it would be indicating that this digit here should be the one to flash. If I enter 3, then these 2 digits should flash. 4, it'll be this one. 5, these 2, etc. It's just a binary format. So it enables me to either flash all the digits, 2 of the digits, or whatever I want to do. But fundamentally, the master on the I2C bus doesn't need to worry about it. You can just set the pattern and allow the ATTiny to take care of it. The other thing I've got is a flash period, which is the period I want it to be on and off. Now, as far as I can tell, the ATTiny doesn't really have this clock is not in milliseconds. I haven't figured out exactly what it is in at the moment, or I'm not worrying about that, but 50 units or whatever this is approximately 150 milliseconds. But we can change that. Again, I've added that as a parameter which we can then change. Then I have flash date on or off. So when we're flashing, basically if the state's on, it'll just keep track of whether the LEDs are on or off. So we can just toggle between those states. So now the variables that we've added. I've also added a time variable, and we'll come to that in a bit. So if we go down to the on receive event, basically this is where the I2C data gets processed. So we have basically first 2 bytes. First is the command, the second is the value. So I showed you before the display number and the set I2C address, but we've now got a flash pattern and a flash period. So what we now do is we have this flash pattern. So basically the second after we send the hex 010 to indicate it's the flash pattern command, we then send a byte which is the flash pattern. Obviously the bit 6, 7 and 8 don't get used because we've only got 6 devices, but it's the first 6 bits get used. I have another little tidy up function here, which is when we go to turn off the flashing, if the digit is currently off, we want to make sure once we stop flashing, we want to make sure that all of the bits are on. So this basically says that, okay, if we get a command to turn the flashing off, make sure the flash state is set to true and update the display to make sure everything is currently on. This update display is where the is where most of the flashing occurs. And you can see, if you remember, if you go back and look at what I had under the display number, before I actually had this writing the information to the 8-bit shift registers. Now what I have is this just stores the information into the byte array, which is the display data. You can consider it like that. And then I have abstracted out the commands to actually take that data and display it into a update display method, which you can take a quick look at. So basically in this update display method, the only new things are we've basically got this state, which is on or off, and before, without the flashing, everything which we had was just exactly what we have in the second half of this if statement. But what we now have is we query the bit in the flash pattern based on which digit we're currently writing into the buffer. If we are, 1 indicates that it should be flashed, and if it should be off, then what we do is for that digit we just write all zeros into its register. All other cases we just write the original data. Okay, so if we're flashing and if we want it to be off, it's the first one where we just get all zeros, otherwise just display it as normal. So this now is basically the update display method, and the only thing we now have left is obviously we need to have something checked periodically. So now I've had to add code into the loop method, which gets processed in a continual type loop. Now it's critical that we don't have any blocking functions in this loop. If we have a blocking function, it will mess up the I2C interface and it'll be a pain. So I'm using this function millis, which on most Arduinos returns back the milliseconds since the microcontroller was powered up. It returns an incrementing number, but it's not in milliseconds on the ATTiny, and at this point in time I haven't spent any time investigating why or what it's doing, but basically I'm taking time when the unit gets first powered up. I then add the flash period, which for me at the moment 50 works quite well, and then basically I wait. So if this loop's going continually, only when we exceed that time period, what we then do is we update the display with the current state, and then we invert the current state so that the next time we hit this loop we'll turn it off. And then what we do is we update the current time with the time that it is now. So we have a rolling period. Every time plus the flash period, it will increment on, off, on, off. And it'll keep doing that forever. Now, we might want to put in, we could put in another check that if the flash is disabled, don't bother doing this, and we could just add that in. It doesn't hurt. If flash equal to 0x00. So I can do that. So that basically means that if we are not flashing, if there's no flash pattern set, then it will never get to this bit of code, and it will just be a more tighter loop. Never hurts to do something like that. Anyway, let's do the fun stuff. Let's program it and see if it works. Okay, so being careful with the ATTiny. Okay. Okay, so we have the ATTiny connected. Let's first of all make sure we save this sketch and upload it. And a few seconds later, and that looks like it's been uploaded. So let's see what it can do. Okay, so we've uploaded the code to the ATTiny. Let's now quickly take a look at the display. So let's get rid of this. Let's first of all get something on the display. Okay, so we haven't broken anything. That looks like it's displaying okay. I wonder if I can zoom in, if it makes it any better. Squeeze in. Yeah, I'm not sure if that's any better. I mean, anyway, we can see. You get the idea. You can see the what's going on there. Yeah, let's just zoom out. It doesn't look great. Anyway. Okay. So we've uploaded the numbers 0 through 6. Now, this is where the new stuff happens. So what we want to do is basically we're going to write send command 10, which is the command to start flashing. And if I send ff, it should make all of the digits flash. So let's see what happens. Okay, it works. So we now have all of the digits flashing. Now, in theory, let me just check what the command was. So the flash period is 11. So it's currently set to 50. So if I set it to just 100, that should be twice as slow. And there we have it. So we can change the speed. That appears to be working fine. Again, if I want to make it go faster, excuse me. We can make it go faster, and in theory, if we go back to the other command, if I just want, sorry, not command line. If I just want like one digit, it should be, this digit should be flashing now. Okay. And in theory, if I do 2, there we go, 2. And if we did like 3, it should be the first 2 digits. There we go. So we've now got a few extra commands on the I2C interface bus, which allows us to do some simple things like offloading the ability to make digits flash down to the ATTiny. Okay, so I'm still going to be playing around with this interface, adding some more functionality, but going to finish the video there for today. If you have any questions or comments, please leave them in the section below. And if you could click the like button, it would be appreciated. It does help increase this channel. So thank you for watching and have a great day.